Hello everyone. Here we would like to understand a very important concept, parallel axis theorem. So the parallel axis theorem relates the moment of inertia of a section or area about a given axis to the moment of inertia of the same section about the parallel axis passing through its centroid. It's very simple. Suppose we have a section here, friends. Section I'm referring to a particular area of cross section basically. So if I say I would like to find the moment of inertia of this particular section about certain axis, let's say this axis. So this is an axis about which I would like to find the moment of inertia of this section. That is why it is written the parallel axis theorem relates the moment of inertia of a section about a given axis. So friends, this is the given axis. So I is the moment of inertia of this section about this axis. Okay. So it relates to the moment of inertia of same section. Moment of inertia of same section means this area whatever is given to us. So moment of inertia of same area of section about a parallel axis. Parallel axis means an axis parallel to the given axis, friends. So I will draw a parallel axis passing through its centroid. So I have drawn a parallel axis here, and this parallel axis is passing through the centroid of, so centroid means C. I have taken C as the centroid of this particular area or section. So it gives the relationship between moment of inertia about given axis and the moment of inertia about a parallel axis passing through the centroid of the given area. So the moment of inertia about this I am going to call as IC. So if you see here, the same thing I have drawn. This is the area or given section, friends. So this is the given section and this is the centroid of the section. A is the area of the section. And the moment of inertia of this particular section or area about its centroid is IC. Okay. So about this axis, which is called as centroidal axis, is IC. So we are interested to find the moment of inertia about this axis, which is over here. Okay. So according to parallel axis theorem, the moment of inertia of this section about this axis, that is I, equal to the sum of moment of inertia of the same section about the parallel axis passing the centroid. So I equal to IC plus area of section and the square of perpendicular distance between them. Okay. So if you want to find the moment of inertia for this section about this axis, then what do? You find out the moment of inertia of the same section about an axis which is passing through centroid and parallel to the required axis. Okay. So you find out IC and then in that you add area of the section into square of distance between them. Okay. So this is how we can find out the moment of inertia of a given section by using parallel axis theorem. So this is basically, this equation is the parallel axis theorem. So let me give an example how to use parallel axis theorem here. Suppose we have got a rectangle. So this is a rectangle, let's say. So let's say friend, this dimension is B, that is width of the rectangular section, and this dimension is D. D is called as depth of the rectangular section. So suppose you would like to find the moment of inertia of this particular rectangle about its base. So I would like to find the moment of inertia of the section about this particular axis, which is base. Okay. So the moment of inertia about base is, I can call it as I about its base. Now, in order to find the moment of inertia of this rectangular section about its base, I have to find the moment of inertia of the same section about a parallel axis passing through its centroid. So this is going to be centroid, friends. For instance, so I will find out the moment of inertia about an axis which is parallel to the required axis and passing through its centroid. So this I can say IC. So in the previous examples already we have calculated the moment of inertia of a rectangular section about this axis which is passing through its centroid, friends. So it is nothing but B, that is width, D, that is depth, BD cube by 12. So this already we have calculated. So if I use the parallel axis theorem, so by parallel axis theorem, I can say moment of inertia about this axis, that is I base, will be equal to the moment of inertia about the parallel axis passing through centroid, that is IC, plus area of the rectangle, that is A, into square of distance between two parallel axes, that is H square. So friends, if you see here, this distance, which is the distance between parallel axes, we can find out from the geometry itself. So this dimension is D, that is depth. This will be D by 2. Okay. So now let's substitute it over here. So moment of inertia of rectangular section about its base will be IC's BD cube by 12 plus area is B into D, friends. and h is d by 2, so it is d by 2 square. Now if you simplify this is going to be d square and this is going to be 4. This is going to be bd cube by 4. So this is bd cube by 12 and this is bd cube by 4. And the next one is bd cube by 4. And here I can just simplify it, multiply by 3 here and 3 here. So bd cube plus 3 bd cube by 12. So bd cube plus 3 bd cube, 4 bd cube, 4 by 12 is 3. So this will be simplified as bd cube by 3. Okay. So we got the moment of inertia of this rectangular section. About its base axis is bd cube by 3. About its centroidal axis is bd cube by 12 and about its base axis is bd cube by 3. So like this we can use the parallel axis theorem for evaluation of moment of inertia of a section about various axes.